Good evening, ma'am. My name is Sai Punit from Computer Science and Engineering. And today my topic, Internetwork Concepts. What is networking? Networking, Internetworking refers to the practice of connecting multiple distant networks using standardized protocols to enable communication. It also devices on different networks, such as LANs or WANs, to exchange data transparently across physically and logically boundaries. The Internet is the large example of an internetwork built by linking millions of smaller networks worldwide. Internetworking relies on gateway routers and switches to forward data between networks with different addressing schemes. The goal is to create a unfinite communication fabric despite underlying network heterogeneity. Key concepts of internet working. Routers are critical devices that determine the best path for data packets to travel between networks using routing tables. Gateways serve as protocol transporters, enabling communication between networks that use different communication standards. Switches operate within a single network but support interworking by efficiently forwarding frames to appropriate segments. Firewalls provide security at network boundaries by filtering incoming and outgoing traffic based on predefined rules. Network interface cards allows and devices to connect physically and logically to a network, forming enter points to the network. The role of protocols in internetworking. Protocols define the rules and convenes for data exchange between devices across interconnected networks. The TCP and IP protocol site is the foundation of modern internetworking, providing end-to-end communication services. IP Internet Protocol handles addressing and routing, ensuring packets reach the correct destination network. TCP ensure reliable, ordered delivery of data, while UDP offers faster but communicationless transmission. Protocols operate in layers, allowing modular design and interoperability between different hardware and software systems. Next, addressing and subnetting. IP addresses unequally identify devices on a network, enabling routers to forward packets actually. IPv4 uses 32-bit addresses while IPv6 uses 128-bit addresses to accommodate more devices. Subnetting divides a large network into smaller, manageable subnetworks to improve performances and security. Subnet makes determine which portion of a IP addresses represent the network and which identifies the host. CIDR classless inter-domain routing allows flexible allocation of IP addresses using variable length subnet marks. Next, routing forwarding data across networks. Routing is the process of selling. Path is a internetwork along which data packets travel for sources to destination. Routers use routing table to store information but about reachable networks and the best path to reach them. Static routing involves manually configured routers suitable for small stable networks. Dynamic routing protocols like OSPF and BGP automatically update routing tables based on network changes. Routing decision consider metrics such as hop count, bandwidth and latency optimized performance. Dynamic routing protocols. Dynamic routing protocols enable routers to share topology information and adapt to network changes automatically. Interior gateway protocols like RIP and OSP, RIP and OSPF are used within an autonomous systems to manage internal routing. Exterior gateway protocols such as BGP handle routing between different autonomous systems on the internet. Distance vector protocols share full routing stable with neighbors at regular intervals. Link state protocols build a complete map on the network and compound shortest path using uh, Dijkja's algorithm. Network addresses translation NAT. NAT allows multiple devices on a private network to share a single public IP addresses when accessing the internet. It translates private IP addresses to a public IP addresses at the router boundary. NAT conserves IPv4 addresses and adds a layer of security by hiding internal network structure. Port addressing translation is a common form of NAT that maps multiple private addresses to on a public addresses using proto numbers. While useful, NAT can complicate pre-to-pre applications and require careful for service like VoIP. The Internet Protocol in detail. IP provides intercalls bit effort delivery of diagrams across interconnected networks. Each IP packet contains a header with the source and destination addresses. TTL protocols types and fragmented details. IP does not grenades delivery order or error checking. These are handled by higher layer protocols like TCP. IPv6 improves upon IPv4 with larger addresses, headers but built-in server and better supports for mobility. Interworking in the OSI model. The OSI model provides a layered framework for undertaking network. Communication with interworking primarily occurred at layer 3. Layer 3 handled logical addresses and routing across multiple networks using protocols like IP. Layer above manage and end-to-end communication between layer below one to delay with the physical transmission. Allo- AI thought TCP and IP does not securely follow OSI. The model helps explain how interworking integrates with other network functions. Challenges in networking. Scalability in a major challenges as the number of connected networks and devices continues to grow exponentially. Heterogeneity differences in hardware protocols and topologies requires robust translation and compatibility mechanisms. Addresses exhibitions in IPv4 has driven the adoption of IPv6 and technologies like NAT to extend stability. Next, real world applications of interworking. Enterprises networks use internetworking with connected branch offices, data centers, and remote workers securely. Uh, IoT systems depend on interworking to connected sensors, actors, and control systems over devices networks. Academic and research networks like internet to use advanced interworking support high-speed collaborations. Future trends in internet networking. Software-defined networking separates control and data plans, enabling centralized programmability. Network management. Network function virtualized replace dedicated hardware with virtualized services running on AI-driven network automation is emerging to optimized routing, detect and self-half networks failures. Thank you, ma'am.